Algebra 1, Lesson 66, Simplification of Radical Expressions and Square Roots of Large Numbers. So when they say simplification of radical expressions, we're just talking about simplifying square root addition and subtraction problems. So if we have square root of 18 plus square root of 8, we need to find a way to simplify that. So we're going to be using all the tools we know about radicals, which is that we can factor them, and then we can add like terms if they have the same base or the same square root number. So if I simplify square root of 18, that'll factor into 2 and 9. 9 factors into 3 and 3. I have one pair, which means square root of 18 is going to be 3 times the square root of 2, because 2 gets trapped under the radical. Now let's do square root of 8. We get 4 and 2. 4 goes into 2 and 2. I've only got one pair of 2's. So that means the 2 becomes a whole number, and then this 2 is trapped in a radical. So when I've rewritten both these numbers, what I actually have is 3 root 2 plus 2 root 2. And we should see that these are like terms and can combine. So I just combine the coefficients. 3 and 2 gives me 5, and then the radical does not change. 5 root 2. That becomes the answer. So that's simplification of radical expressions. That's a pretty easy example. Let's do a tough example. Let's say we have square root of 27 minus 3 times the square root of 18 minus 6 times the square root of 45. So let's start with 27. That's going to be 3 and 9. 9 is going to be 3 and 3. We have a pair, and then we have one left out. So this is going to be rewritten as 3 times the square root of 3. Put our minus sign. From here, 18, we have 2 and 9. 9 is 3 and 3. That gives us a pair. Now, the thing we have to look out for here is this whole number 3 comes out of the radical, but there's already a 3 here. So what we do is we take this one 3 that's outside and we multiply it. So any number that comes out of the radical gets multiplied by any numbers outside that are touching. So this becomes 3 times 3, which gives us 9, and then the 2 is still trapped inside, so we get 9 square root of 2. Last, and then I'll copy that minus sign. Then we have 6 times the square root of 45. This is 5 and 9. 9 is 3 and 3. We have a pair of 3's. The 5 gets trapped, and then, like I said before, we take this single 3, multiply it by 6. That gives me 18 times the square root of 5. Now, we're going to look for any like terms, and we have a 3, a 2, and a 5, which means there are no like terms, so this is our final answer. So that's it for that section. Now let's talk about the square roots of large numbers. And square roots of large numbers is actually way simpler than this. All we're doing is stuff like this. Let's take the square root of 500,000. So the fastest way to factor square roots of large numbers like this with all these zeros is to factor out the lead number, or the 5. So if I were to factor this, this would be 5 times 100,000. All right. So if you guys remember expanded notation, this is kind of like expanded notation. We just take the place value of the 5 times 1,000, or 100,000. From here, I'll take the 100,000, and what I'm going to do is I'm going to start separating the zeros. So this is the same as, we'll put 2 zeros over here, 100, and then 3 zeros over here, 1,000. So that's the same as 100 times 1,000. And then I'm just going to split zeros again. The 100 will factor into 10 and 10, which I see I've got a pair. I can stop. And then the 1,000 is going to factor into 10 and 100. So the 100 is going to factor into 10 and 10 again. So I've got 2 pairs of 10. And then in this number 10, I'll go and factor this to get 2 and 5. So what I see here is I have a group of 5 and 2 groups of 10, and then the 2 gets trapped in the radical. So I've got 5 times 10 times 10 times the square root of 2. 10 times 10 is 100, and 100 times 5 is 500. So the answer is 500 times the square root of 2. So the only thing to remember here is when you're finding the square roots of large numbers is factoring these multiples of 10 and 100. And again, you just split the zeros. So like 100,000 had 5 zeros in it. I put 2 zeros over here. That gave me 100. I took 3 zeros, made them 1,000. And then when you're splitting the zeros, each side gets a 1, or else, 3 zeros isn't a number. It's just 0 3 times. So that's really the tough part here, is being able to split from this number into a number in 100,000, 10,000, maybe a million, and then splitting the zeros up from there. If you have any questions, let me know on Moodle, and I will see you in class.